Activity 7 examined what happens when two plates move away from each other. This activity examines what happens when two plates collide. Subduction occurs when two plates collide, pushing the edge of one plate below the edge of the other. Subduction can occur between two oceanic plates, between two continental plates, or between an oceanic and a continental plate. This activity focuses on the interactions between continental and oceanic plates. Where the two plates collide, a deep ocean trench forms. Ocean trenches are the site of major earthquake and volcanic activity. The volcanic activity results in the formation of new volcanic islands, such as the Aleutian Islands or the islands of Japan or the Philippines. The islands form in arcs rather than straight lines due to the fact that the plates are moving on a spherical Earth. In Activity 8, students model subduction and infer the effect of colliding oceanic and continental plates on the Earth's crust. This activity will take about 40 minutes. The vocabulary introduced in this activity is basalt, granite, and subduction. For this activity from the kit, you will need the plate puzzle pieces from Activity 6. For each team of 4, you will need one piece of thick foam, one piece of thin foam, and one magnifier. For the class, you will need 2 bags of basalt, 2 bags of granite, and 1 roll of masking tape. In addition to the kit materials, you will also need to supply a ruler for each team of 4. You will also need a ruler that's heavy enough and thick enough to have the weight. So it could be wood or metal. In the previous activity, students are reminded that they learned what happens when two plates move away from each other. Tell them that in this activity, they will try to solve the mystery of what happens when two plates move toward each other. Divide the class into teams of 4. Give each team a magnifier and 1 sample of basalt and granite. Have the students examine the rocks closely and compare the 2 rocks. Johanna, let's take a look at our 2 rock samples and tell me what you can see and tell us about these 2.
Well, if I look at this one, I see little black specks like polka dots in it. It has a little pink and a little bit lighter color, and I even see some little shiny crystals in it. This one, okay, as I look at this, I really don't find much difference in the particles. They all look pretty uniform, just a dark gray.
Okay, thank you. We want to name the darker rock as basalt and explain that the crust beneath the oceans or oceanic plates is made primarily of basalt. Name the lighter colored rock as granite and tell the students that the continental plates are made primarily of granite. Although granite has visible pieces of minerals, basalt also contains grains of minerals, but most are too small to even see with a magnifier. Go on to explain that rocks with smaller grains tend to be heavier than rocks with larger grains. Ask the students which type of rock is heavier, granite or basalt. They should say basalt. From this information, students can answer the question, which type of plate is heavier, continental or oceanic? They should respond, oceanic plates are heavier. Distribute the students' plate puzzles from Activity 6 and have them assemble the pieces. Ask them to locate the Nazca and South American plates and move these plates in the directions of the arrows. Johanna, what kind of plates are the Nazca and South American plates?
Okay, I see no continent on the Nazca plate, so that must be an oceanic plate.
Okay.
I see a continent on the South American plate, so that must be a continental plate.
Okay, so if we took these 2 plates then and we pushed them in the directions of the arrows, you want to try that again?
Well, they're running into each other. They're colliding.
Okay. So we said before when we looked at our rock samples, we said that that the oceanic plate was made mostly of what type of rock?
Basalt.
Well, let's put the basalt then on our oceanic plate.
Okay.
And what about our continental plate?
It has mostly granite.
Okay, so we have the heavier oceanic plate, the granite on the lighter continental plate. What do you think will happen then when our heavier plate collides with our granite that is a lighter? What do you think will happen?
Well, it's kind of hard to tell, but I think that probably we could find out by doing something here.
Okay. We're going to accept all predictions without commenting from the students. Okay, Johanna, let's model what happens when two plates collide, okay? We have two pieces of foam right here. We have a thinner piece of foam and a thicker piece of foam. What do you think the thinner piece of foam would represent?
I think the thinner piece of foam would probably represent the ocean, the oceanic plate, because we know that it is thinner.
And then the thicker foam would represent the
Continental plate,
Okay.
because we know that it's thicker.
Okay, remember when we were looking at our rock samples too, we have granite and basalt. And what did we say the oceanic plate was made of? Which?
Basalt. It's
okay.
actually heavier,
Okay.
but it's on a thinner crust.
Okay, and then our granite, which is a lighter weight rock, is going to go on our continental crust, and
Right.
that's made of that. So we want to, when we show this model, we want to represent then the thinner crust as having some more weight. So we're going to take this ruler, and that's
Okay.
going to represent our heavier weight, and we're going to tape that securely onto our piece of foam. And then in the classroom, as we set this up, we would set this up between two desks. For our model, we're going to use these two tubs for our plates to set on. So Johanna, if you'll put your oceanic plate on there, I'll put my continental plate on there, and then if you'll lightly push, I'll push mine, and we'll see what happens when they meet.
Okay.
So what this is called is subduction, and
Okay.
subduction is when a heavier plate falls down below a lighter plate. And if we get down and look, we actually can see a V shape that's right here, which is actually a trench that forms
Okay.
when our plates meet. As you were explaining subduction to the students, you may want to use diagram 8.3 in your teacher's manual. Lead the students to a further understanding of subduction by asking a series of questions about what the crustal plates are made of. What is directly under the crust? What do they think will happen to the rock at the edge of an oceanic plate when it collides with a continental plate? What will happen to the rock when it sinks into the magma? And how might they describe what would happen to the edge of the plate that is sinking? Students should be able to give answers that will suggest that they understand that the hot magma in the mantle will melt rock and the sinking plate will melt and become part of the magma in the mantle. The students look again at their plate puzzle pieces from Activity 6 and focus on the Nazca plate where it meets the South American plate and tell what they think is happening. Then revisit the mysteries chart and ask them to connect what they have learned in this activity to help them solve the second mystery, which is, what happens to plates that move toward each other? Students should be able to conclude that when a heavier oceanic plate and a lighter continental plate collide, that the heavier oceanic plate sinks down into the mantle, melts, and becomes part of the magma through a process called subduction. Write the equation oceanic plate plus continental plate equals subduction beneath the second mystery. Students may come up with the question on their own if enough wait time is given. What happens if a continental plate collides with another continental plate? If not, leave the students with the question, in what way is the mystery only partially solved? Tell them that they will learn the answer in the next activity. For cleanup, have students remove the rulers from the pieces of foam and discard the tape. Collect the rock samples and return them to the bags. Return the foam, magnifiers, tape, and bags of rocks to the kit. Collect the students' labeled bag of puzzle pieces and store them for use in Activity 9. Review page 8 in the Delta Science Reader.